So that positive slope, we do have a positive 2 over 5, so that does correlate. So positive 2 over 5, positive slope going up from left to right. All right, in the previous examples, they were already in slope-intercept form. They were in y equals mx plus b. In this example, it is not. This example is what we call standard form. Now, we are going to learn how to graph directly from standard form in a few lessons. However, today what we're going to do is we're going to actually convert this into slope-intercept form. Now, standard form is ax plus by equals c. It's where my x and y are on the same side and it's equal to the constant. So we're going to turn this into slope-intercept form. So we want to turn it into y equals mx plus b in order to graph it. Okay? So to do that, we are going to solve for y. That is the reason we learned how to do literal equations in the first unit, so that when we had to do that here, it was already something we were aware of. So we have 2x plus 3y is equal to 6. And we're going to solve for y in order to get y by itself. All right, so we're going to do 2x, and we're going to subtract that on both sides. So that gives me 3y is equal to negative 2x plus 6. I put the x first just because the x comes first in the slope-intercept form. I'm going to divide by 3. And at that point, I want to simplify. I'm going to make this as easy as possible when I go to graph. So negative 2 divided by 3 and 6 divided by 3. So negative 2 divided by 3 is going to be negative 2 over 3x. 6 divided by 3 is going to be plus 2. So we are now going to be graphing this in slope-intercept form, since we have solved for y. All right, so we're going to start with this problem. We're going to start with our y-intercept. Our y-intercept is at 2. So we're going to plot at 2. And my slope is negative 2 over 3. Now, the most common mistake that I see students make is if there's a negative in front of the fraction, students will make it like this. They'll make it negative 2 over negative 3. And that's not correct. Negative 2 divided by negative 3 turns into positive 2 over 3. And that's not what we want. That's not what we're looking for. So my recommendation is whenever you have a negative, you always put the negative in the numerator. Okay? So that is going to make it so we have negative 2 over positive 3. And then I know that I'm going to go down 2 units, and I'm going to go to the right 3 units. All right, so from my y-intercept, I'm going to go down to right 3. I'm going to plot that new point. I can do it again if I want to. I'm going to go down to right 3. And I can make that equation of this line. A few things to also connect here is when we're talking about a positive slope or negative slope. When we read a graph from left to right, just like we read a book. So if I'm looking at my graph here, if I'm reading it from the left side to the right side, it's going down. It's going down because it has a negative slope, okay? If it has a positive slope, then it's going to go up from left to right. If it has a negative slope, it's going to go down from left to right. Just something to keep in mind to make sure you did it correctly. Now, the last thing I want to review is you can actually check your graphing in Desmos. So I've got the Desmos version pulled up here, and I'm going to simply type in my equation. So y equals negative 4x plus 3. Now, a couple of things that I want to check while we're looking at this is the y-intercept. So I can click the y-intercept and it'll give me the 0.03, which is what we got. And I can do my rise over my run. So the point that we had for when we did rise over run, when we went down 4 and right 1, was at the point 1, negative 1. So if I go to my graph, I should be able to see that at 1, negative 1, there is a clear point there. We also identified another point at negative 5, 2. So if I go down, to negative 5, So if I go and adjust that, I can see that I have 2, -5. Now, the other thing is when I'm doing this, I'm actually holding my finger down and sliding it on the graph just to check that out. And that does, in fact, match the graph that I got. Also, I have the next one, so I'm going to clear that out. I have y equals 2 over 5. Now, if I type x right now, the x is in the denominator, and that does not create a line. So we're going to delete that. We're going to hit this arrow that's in the bottom screen that's going to move my cursor out of the denominator to the right. And now we're going to type x minus 1. I see that my y-intercept, I clicked the y-intercept, and it was at 0, -1. And we should have a point at 5, 1. So if I go to 5, 1, I can see at 5, 1 that clearly is a point there. I can also type the point 5, 1, and I can see that it lands on the graph. Okay, so these are just ways to check behind yourself. All right, the other problem that we had, now I'm going to do this both ways. I'm going to put it in standard form. And I can actually see my graph here. I can see that my y-intercept is at 2, and I can see that I have that value at 3, 0. I can also graph the one that I solved for, y equals -2 over 3. Make sure I get that cursor out of the denominator, x plus 2. And I should see the exact same graph. I mean, because it is the same line. If I click the color on the actual Desmos, I can see it turn off and on, that they're on top of each other. And again, that's just a way to check yourself with your graphing. I hope this helps.